Hello everyone, this is Praful. So today we are going to start our new project which is based on the D flip-flop, the Verilog code which is based on the D flip-flop, the functionality is D flip-flop, and we are introducing the VIO concept. First we will introduce the steps to you. The steps, first we will modify the counter code accordingly. The module ports should be modified to make all input into bias and the output as edge except clock. So we are introducing the VIO, which is a virtual input output. So the input of the D flip-flop will be the output of our VIO, and the output of the D flip-flop will be called as the input of our VIO. So create a VIO template using IP catalog, which is in our Vivado. So add the probes. The probes is input and output, and change the probe with width accordingly. Okay. Now click the IP sources and then instancing template and the VEO and VHO. So VEO for the VST. Okay. So then the last, sorry. So now the copy paste the template inside your code. So now change the module probe names of the VIO template. You just copy. Input and output should be assigned according to the comments mentioned there. Okay, let's see. First we will wait a second. Okay, so now just create a project. The project is my DFF VIO. This next. This is a RTL project. We will be added to add source. Okay. The category which is the general purpose, and the package is 236. The family is Arctic 7, and the speed is -1, and we are going to this 236.06 LUT element is to 20,800. Okay. So next, new project sample. I hope you know the concept of VIO. So I will not explain that much about VIO. Just implementing VIO. Okay. So first we will add the Verilog file, the D flip-flop file. Add the file. This is our D flip-flop.v file. We have to change in finish. Okay. So this is our D flip-flop file. We have to change this module D flip-flop. Just close all the screws, and this is a reg. Q is the reg, and hope you know that this is the output. This is the output of a D flip-flop, but the input of a VIO. This is input. So this will be the wire, and this will be the output of VIO. Okay. So this is an input clock. Wire always block is there. Okay. Now just save it. Okay. So now go to the IP catalog. We have to search for the VIO. This is a VIO. Just double click on that. You will find this general options. The probe input. We need only one probe input and one probe output. So as it is, just click OK. Number of jobs we can do is like maximum to the 4. So just click and generate. If background running task is running, please wait until it's complete. Wait a second, just close all the background tasks. generating. Out of the context module run was launched for the generating output products. Okay, now it is generated. I think so. We have to go to the IP sources. Just click on that. The instantiation template. There is a file called .vio, which is a Verilog file. Let's click on that. This is just like a black box. We don't know what is the functionality of this IP. We can just copy paste this VIO module to our D flip flop. So the input of our VIO is Q. Okay, so just delete this and Q, and this is T. You can change the name also. What's your name? Okay, input via clock. Okay, now just save it. We have to elaborate the design. We have to elaborate the design so that we can add our constraint file. So elaborate the design. Okay, now it is going to elaborate. It will take some time. Now this is our IO planning view. We can change this to our floor planning view also. But it's good that seeing an IO planning. Okay, so now we have to change this. This is our clock. So clock is in, and the clock package pin. The package pin is W5. Okay, and we have to change our LVS to 33. Anything more? No, I don't think so. Let's save the constraint file. TFFVIO constraints. Okay, so our constraint file is saved. Now we can directly go to the generate bit string part. Okay, it will take some time. It will take because the number of jobs is only 4. So wait. 4. Launch. Okay, just generate it. The running the synthesis design. After generating the bit string, we have to add this FPGA board to plug it on. Synthesis design. Actually, we are using the VIO, so we don't have to see our FPGA board in the video. We're developing a VIO hardware, so that we can check the functionality in our windows. Initializing design. Okay. So the processor is very slow. That's why you're waiting too much. The time is taking. Actually, we can do the run synthesis and run implementation part separately also, but it's easy for us to just implement, generate the bit stream. So you can check the reports, timing reports, and all the reports like constraint and all these things by doing separately after the synthesis, before the synthesis, after the simulation. You can check our schematic also of T flip flop, elaborate the design. We actually what we are doing in that is we are defining the constraint running opt design. It is optimizing the design according to the Vivado. There are many instances. There are so many instances in the Vivado, so it is useful to optimize the circuit design which we are using. Sorry for the delay. So the board which I am using is that Basis 3. It's a feature the Xilinx Arctic 7 FPGA board. It's taking too much time. Actually, because of OBS, the process is running very slow. I think. Actually, my voice is very low in this video because I'm in library at that time. Just, running place design. Actually, FPGA can be used as a prototype for ASIC. You can check the functionality of our log file RTF code after the synthesis implementation in FPGA. So it is useful as a prototype. But after you going to the ASIC side, then it will be easy for us because we have checked the functionality of our code. Running route design. write the bit stream. Write bit stream. Okay, so now the open hardware. Just connect to the what port is this and just open hardware. Okay, now hardware target is open. Just click on auto connect. The program is already okay. So now we are going to program our device. This is our stream file program. It will open. Okay, this is a HWVIF file, hardware VIF file. Just click this for checking the functionality. Just click on both Q. Okay, just check. If we keep the top 0, it will the output is also 0. If you give the 1, then the output is also 1. So our flip flop is working fine. Okay, so that's all about the flip flop using VIO. We don't have to see our hardware block, and we don't have to adjust the and switch it on the blocks, the switches, so we can check. Okay, 1 to 1, so it is working fine. So that's all. Thank you.